In this lesson, we're going to look at ways to use the factor theorem to find all the factors of a polynomial and some shortcuts. Like, for example, we have the graph of this polynomial right here, and we want to look to see if we can spot any x-intercepts right off the bat. Well, -1, -2, -3, that's -5. I also see 3, but the other one I'm not so sure about, so I might have to estimate it. Looks like -1.5, but I'm not quite sure. I'm going to put a question mark there. Now, we can plug in each one into the function and see what values we get for f. Now remember, there was another way to test that. What we could do is plug those in using synthetic division. So let's try that. If I try -5, let's see, we've got 2, 7, -24, and -45. Now remember, if -5 is one of the zeros, that means x plus 5 is a factor, and I should get a remainder of 0. So if I bring down the 2 times -5 is -10. Add, you get -3. -3 times -5 is 15. -9, 45, and 0. It is. So that means I have x plus 5 as a factor, and then this would be what multiplies by x plus 5 to get my original back. That's 2x squared minus 3x minus 9. Now let's see if it works with, what did we also see? I believe 3 is a possible one. Okay, 2, 7, -24, -45. Bring down the 2. 2 times 3 is 6. 7 plus 6 is 13. 13 times 3 is 39. 39 plus -24 is going to give me 15. 15 times 3 is 45. And we also get a remainder of 0. So that means another way I could factor that polynomial is x minus 3 times 2x squared plus 13x plus 15. Now think of this as ways you can factor off of a factor tree. Because, like, for example, I could take 12 and do 2 and 6. Or I could do 3 and 4. In other words, there's multiple ways to get started when you're factoring something. Now let's see what happens when we factor our quotients. So let's take the first one. 2x squared minus 3x minus 9. Now, I know some of you like to use the box to factor that if you have trouble doing a guess and check. So let's remember how to work that. First term we go here, last term here. Now these other two terms are going to multiply to be the same thing as these two together, which is -18x squared, but add to be -3x. Well, our only options are -6x and +3x. What goes into both 2x squared and -6x? 2x. 2x times what is 2x squared? X. 2x times -3 gives me -6x. And x times a +3 gives me 3x. And let's double check. Does 3 times -3 give me -9? Yes. So here are my factors. So, for this setup, I would have had 2x plus 5 times 2x plus 3 times x minus 3. Now let's see what happens when I factor the quotient over here. Again, I can use the box. And I'll do it up here this time. 2x squared, 15. What's going to multiply together to give me, what's that, 30x squared, but add to be 13? Well, that's easy. That's 10x and 3x. What goes into those? 2x. 2x times x is 2x squared. 2x times 5 is 10x. X times 3 is 3x. And 3 times 5 is 15. So on this side, I would have had x minus 3. And then these factors are 2x plus 3 and x plus 5. Now let's compare. Do we still get all three of them? It's just in a different order. It's the same as doing a factor tree. We're still going to get all the same factors. They just may not be in the same order depending on which one we started with. So based on this, we can fully factor that polynomial to x plus 5, 2x plus 3, and x minus 3. In other words, I can find all of my roots very easily. Now let's look at another way we can use this. If I know one of my x-intercepts, I can get started. So let's see. If I look at this one, I see 6 really clearly. So let's use synthetic division and divide by, well, this would actually be the factor x minus 6, right? Okay. Our leading coefficients, we got 3, negative 14, negative 28, and 24. Now hopefully, if the picture is right, I'm going to get a remainder of 0. Bring down the first term. 3 times 6 is 18. Negative 14 plus 18 is 4. 4 times 6 is 24. That'd be a negative 4, negative 24, and 0. Now what's nice is, remember how we talked about almost like a factor tree? I can divide again if I happen to know any other factors. Let's see, it looks like negative 2 is. So that'd be the factor of x plus 2. Let's see if it works. And I can actually divide the quotient by that, sort of like doing that factor tree. Sort of like taking 48 and going, well, that's 2 times 24, and then you break 24 down. We're going to do the same thing here. Let's bring down the first term. 3 times negative 2 is negative 6. It's going to give me a negative 2. Negative 2 times negative 2 is 4. Remainder of 0. And now I'm left with something pretty easy. That's going to be 3x minus 2. So fully factored, this is x minus 6 times x plus 2 times 3x minus 2. Let's look at the next one. Now this one is set up a little different. We don't have the picture, but it's telling me that if I plug in negative 3 into this function, I get 0 as an answer. That means negative 3 is one of my zeros. So I can use synthetic division to factor this. If negative 3 is one of my zeros, that means x plus 3 is one of my factors. Let's see if I can find more. It's 1, negative 13, 12, and 180. Bring down the 1. 1 times negative 3 is negative 3. Add, I get negative 16. Negative 16 times 3, that's going to be 48. Add, I get 60. 60 times negative 3 is going to give me a negative 180. When I add, I get 0. Now this one I didn't have a picture to help me find any more. But let's see what we have left. We have this x plus 3. And the quotient is x squared minus 16x plus 60. I wonder if that factors. Well, sure it does. That's an easy one. X and x, well, it multiplies to give me 60, but adds to be negative 16. It's got to be a negative 6 and a negative 10. We are totally factored. Now, one thing I want you to notice is if we looked at the actual solutions, or the zeros, for all of these, we're going to notice that there's going to be a little bit of a pattern. So I have them written down already, and I want to kind of talk through this. They're written down already right here. On the first problem, the zeros end up being negative 5, negative 3 halves, and 3. The second one is negative 2, negative 2/3, 6. Third one was negative 3, 6, and 10. And here's another example that I didn't get to on the video, but if we look at these integer solutions and look at that constant, Is negative 45 divisible by negative 5? Yes. Is negative 45 divisible by 3? Yes. Is 24 divisible by negative 2? Uh-huh. Is it divisible by 6? Yes. 180 is divisible by all of those. So what's nice is integers have to come from the constant. Now let's look at the fractions. The only ones that had fractions are the ones that have a leading coefficient. Leading coefficients, look at the denominator. That one has a denominator of 2, leading coefficient of 2. Denominator 3, leading coefficient of 3. So we end up with these possibilities of having fractions if your leading coefficient is greater than 1. So let's try a couple of these. So what we are finding, those integers and fractions, are all rational numbers. So this is actually called the rational root theorem. Your rational roots are always going to be factors of your constant. So right here we have 6. So our possible zeros, our possible rational zeros, are all factors of negative 6. So that could be a positive or a negative 1, could be a positive or a negative 2, positive or a negative 3, positive negative 6. That can help us narrow down what we can choose from to try to help factor this a little bit more. So let's try 1. Now I didn't put any fractions here because there is no leading coefficient, so we're good. We know we're not going to have any fractions as rational zeros. It only happens if your leading coefficient is not 1. Alright, so we bring down our first term. 1 times 1 is 1. Add and we get a 0. 1 times 0 is 0. Add and we get a 1. 1 times 1 is 1. Add and I get a negative 2. Did I do that right? Yeah. Negative 2 times 1 and I get a negative 2, and uh-oh, this one doesn't work, does it? Let's try another one. What if we try negative 1? Okay. X to the 4th, x cubed, x squared, x, and the constant. Alright, just make sure I wrote it down right. 1 times negative 1 is going to be negative 1. Add and I get a negative 2. Negative 2 times negative 1 is going to give me a 2. 1 plus 2 is 3. 3 times negative 1 is going to give me a negative 3. Add, I get a negative 6. Negative 6 times negative 1 is going to give me a positive 6. Add, and I get a 0. So this is one of my factors. If negative 1 was a 0, then that means x plus 1 is one of my factors. Now the quotient here is going to be 1 less, so that's going to be x cubed minus 2x squared plus 3x minus 6. Now I could keep going and try synthetic division again, or I can use other ways to factor it. I'm thinking maybe a 2 might work. Let's try 2. Now I don't have to go back to the original. I can use this and try to factor it using synthetic division. Now I just guessed a 2. Don't have all the answers written down. Bring down a 1. 1 times 2 is 2. It gives me a 0. It gives me a 0. Add 6 and 0. It just happened to work. So we still have the x plus 1 out front. Now we know 2 is another 0, so that means I have a factor of x minus 2. And then I have this quotient. Now this is going to be x squared, 0x, and plus 3. Now, x squared plus 3. It's not the difference of squares. It's not going to factor anymore. but it's easy to solve. So let's look at all our answers here. This is going to give me x equals -1. We already knew that was a 0. X equals 2. And when I set this last factor equal to 0, it's pretty easy to solve. Take the square root of both sides. And remember, when you take the square root of both sides, you're always going to have a positive and a negative answer. The square root of a negative number is imaginary. So this is going to be plus or minus I square root of 3. And I have actually found all of my zeros.